Hi everyone. So in today's video we're going to discuss the definition of joint probability density function. So in the previous video we have told what is a joint probability mass function, where probability mass function comes when the random variable takes a discrete values, that is when the random variable follows a discrete distribution or discrete random variable, then we use the joint probability mass function, and when this x and y are two-dimensional continuous random variables, then we have the probability density function or joint probability density function written as f of xy. So a joint probability density function of the random variables xy is denoted by f of xy, and it is called a joint PDF if it satisfies some conditions. So the first condition is f of xy must be greater than or equal to 0 for all x comma y belonging to R. So if there is a region over which these random variables are defined, then for all the values or for all the points in this R, this function f of xy must be greater than or equal to 0. The second thing is that while we were saying about joint probability mass function, there was a thing that summation, double summation over f of p of xi yi or f of xi yi must be equal to 1. The same thing is in the continuous case. We'll get integral over x, integral over y, f of xy, dy dx, or integral over y, integral over x, f of xy, dx dy must be equal to 1. So, for a function f of xy to be a joint probability density function, it must satisfy these two conditions. So, to check whether a given function is a joint probability mass function or not, or for joint probability density function or not, we can verify these two properties.